These are the number 1 graphing quadratic functions in standard form notes. They're from chapter 5.1. So your steps are going to be to draw the axis of symmetry. That's the vertical line that passes through the vertex. The formula for that is x equals negative b divided by 2a, or the one we're going to use is a modified version, x equals negative 1 times b over 2a. So the first thing that you have to determine is your a, b, and c. So here's your standard form equation, y equals ax squared plus bx plus c. You can see I've underlined the a in red, the b in red, and the c in red. So in this case, there is no number there, which means it's a 1. This is negative 6 for your b, and this is 5 for your c. So we're going to go ahead and write that down. So a equals 1, b equals negative 6, c equals 5. Now once you've done that, then you can go ahead and do your step 1, which is to find your vertex. We're going to use this x equals negative 1 times b is negative 6 over 2, and a is 1 times 1. A negative times a negative is a positive, so 1 times anything is that thing, so it's going to be positive 6 over 2. 2 times 1 is 2. 6 divided by 2 is 3. So that's your x axis of symmetry. X equations always go across the x-axis. Let's go ahead and use a different color, something bright. Here's 3. I make it a broken line because it's imaginary. And that is x equals 3. That's the equation right there. Now we're going to go ahead and we are going to find the vertex, which is step 2. So step 2 is the vertex. We have the x-coordinate because the x-coordinate of the vertex is the axis of symmetry. So it says right here, step 1 gives the x-coordinate of the vertex. So the x-coordinate is 3, which means we need to find the y-coordinate. So it says find the y-coordinate by substituting x into y equals ax squared plus bx plus c. So we substitute into this equation. So y equals a is 1. So we can put the 1 in, but we don't have to. X is 3 squared. You can put the 3 in parentheses if you want. It's not necessary when the number is positive. It is necessary when the number is negative. Minus 6 times, here's your x, which is 3, plus 5. You do exponents first in order of operations. 3 squared is 9. But because the exponents and the multiplication are separated with a lower operation, which is subtraction, you can do them at the same time. So 9 minus 18 plus 5. Now, not everyone needs this step, but some of you will. So y equals 9 plus negative 18 plus 5. Since it's all addition, I changed the subtraction to an equivalent addition expression. I know that 9 and 5, this is commutative property. I can do them out of order. 9 plus 5 is 14, plus a negative 18 is negative 4. So y equals negative 4. So that's going to be our vertex. So we're going to go ahead and use a different color, and that's going to be 3, negative 4. We're going to plot it. We look at the equation, y equals x squared minus 6x plus 5. We know it opens up, and we know it's going to be the same size as the parent function because the a is equal to 1. So we are going to, it would in fact go up 1 over 1. We could actually, knowing that it's the same size as the parent function, we could do this. 1 over, up 1 over 1 over 1. We could do it that way, but I'm going to show you a different way because you won't always have that ability to do that because they're not always going to be the same size as the parent function. So now we're going to go to this next part, which is step 3, plot 2 points on one side of the x-axis. So let's go ahead and go to step 3. Now, I'm going to choose the left side because I can see that I have 0 here, and I want to use that 0. I made a little mistake here I want to fix. Let's get rid of this one. For the parent function, it goes over 1, up 1, but then from here it would go 2, and then up 4, 2, and then up 4. So we'll just plot those two. We know that those two are going to work. Okay, let's go ahead and plug a couple of points in. So you go over 1, up 1. And then remember from the parent function it went 2, 4, so you'd go 2, and then 1, 2, 3, 4. 2, 1, 2, 3, 4. Okay, let's get this to work. 2, 1, 2, 3, 4. And then we go back 2, and then up 1, 2, 3, 4. Now, we're going to go ahead and that would be enough points, but we're going to go ahead and check it just to make sure we're right. We know, again, it's the same size as the parent function. Okay, so I'm going to choose 1 because that's where I've got this point. Let's see if it comes out. And I'm also going to choose 0. So we're going to choose, it says plot 2 points on one side. I'm choosing the left side. So choose 0 and 1. For x, and then we're going to go ahead and substitute in 0. So it's going to be y equals 0 squared minus 6 times 0 plus 5. Well, this is nice and easy because 0 squared is 0, 6 times 0 is 0, so y equals 0 minus 0 plus 5. You don't need this step. You could just have gone y equals 5. So the ordered pair, we chose 0 for x, and then we have the y value of 5, so 0, 5. Let's plot that, get the other color. So 0, 5, plot that right there. And then we are going to choose 1 as well. Now, 1 should be which should be 0, because that's where we went 1, and then we didn't go up and down at all for y. So let's see if we're right. So y equals 1 squared. You can put it in parentheses, but you don't have to. Minus 6 times 1 plus 5. And then y equals 1 squared is 1 minus 6 times 1, which is 6, plus 5. Now, some of you need this step, some of you don't, but I'm going to go ahead and do it. Y equals 1. We're going to change subtraction to addition. The 6 becomes its opposite of negative 6 plus 5. So we have y equaling, I can use commutative property, so I've got 1 and 5, which is 6, and negative 6, which is 0. So the ordered pair is x was 1, so we chose 1 for x in this case, 0. And you can see right there, 1, 0. So if we know how to graph a parent function, we can also do this quite simply in terms of we go out 1 and up 1, and we go out 2, up 4. And then remember, we're going to be reflecting our points. Since I have this nice point up here, let's choose another bright color. This is 1 from the axis of symmetry, so it's reflected over. This is 2 from the axis of symmetry, so you reflect it over. This is 1, 2, 3 from the axis of symmetry, so we'll reflect it over. Plot a point. And then I'm going to write all my ordered pairs. So I have 3, negative 4, which is right here. Let's choose, I think I'll go back to black. 3, negative 4, that's your vertex. And then this is 2, negative 3. And this is 4, negative 3. And this is 1, 0. And you can see that one right there. And then we reflected it. Now that's 5, 0. Now really we didn't need any more points in this, but we'll go ahead and write them. This was because we have them, 0, 5. And then this one is going to be 6, 5. And then we're going to make the parabola. Let's get that pink again. And remember, it's curved, so make your curved bottom. Then it comes up through, checking for number sense. The parabola opens up because the a value is positive. And we've got at least 5 points. Here we have 7, but we need at least 5 points. And we have that, so we're good to go. Now you're going to try the next one on your own using the same steps, and then you're going to check your answer when you're finished. Okay, the problem you're going to work on is y equals negative x squared minus 2x plus 1. Don't forget to find your a, b, and c. Follow the steps. I've copied them over for you. On the left-hand side, you can always go back and watch the video if you're struggling. Do this on a piece of paper, because after you finish this one, you're going to try 2 more that will be turned in for a grade. Thanks. Bye. Okay, you can see that a is -1, b is -2, and c is 1. This opens down. We know it's going to be the same side as the parent function because this is a 1. So the absolute value of a, if it's 1, is going to be the same size as the parent function. So it goes over 1, down 1, over 1, down 1, so that's right. And then it's going to go over 2, down 1, 1, 2, 3, 4. You can see that fits on there. So over 1, 2, and then down 1, 2, 3, 4. And you can see that line fits on there, even though we didn't graph that point. And then it would go over 3 and down 9. So 1, 2, 3, and then 2, 4, 6, 8, 9. You can see that it ends up at 2, -7. This will repair over here after you reflect it. So let's just talk about the reflection. So here's your axis of symmetry. You want 1 to the right of the axis, 1 to the left. Down here at 2, -7, it's 1, 2, 3 from the axis of symmetry. So you go 1, 2, 3, which gives you -4, -7. So now you have your 5 ordered pairs. But knowing it's the same size as the parent function, it's the same size as parent function. It opens down because this is -a. But you could actually get your points without even doing the choosing 0 and 2. However, it doesn't matter. Both are pretty simple. And we know it's the same size as the parent function because the absolute value of a, the absolute value of -1, is equal to 1. And that's what tells it to you. So the absolute value of -1 equals 1. That tells you it's going to be the same size as the parent function. Okay, on your piece of paper, label it number 1, graphing quadratic functions in standard form. You need to show your work just as I did in the lesson. Here are your 2 problems. Y equals x squared plus 6x minus 2. And your second one is y equals -x squared plus 6x minus 8. I've provided graph paper for you, so you need to graph it on that graph paper and attach it. We will do one problem when you come to class next time, and then you will be turning these in for a grade.